So now in this video, we're focused on the photodiode right there. We have the photodiode reverse bias. As light falls on it, it will let more current pass through. Of course, the LED here is forward bias. Right there, long lead the anode towards the more positive side, short lead the cathode towards the more negative side. Reverse bias for the photodiode. And there you can see that if I cover the photodiode, the LED turns off completely. We don't have much current flowing right now. But the photodiode is reverse bias. Long lead the anode towards the more negative side of the circuit. Short lead the cathode towards the more positive side. If we're careful enough, we don't need that 220 ohm resistor, but it will limit current when we are working with 5 volts. It'll keep things safe if I get a bright enough light going on there. So we'll begin with that. So this flashlight, if I shine the front, that is a light that turns on and off rapidly. So it'll work better if I use the side light right here. But yeah, I'll cover that up, and you should be able to see the LED gets brighter right there. You can also see the current goes up now that I have the power supply as I get the light. Now, the light on there. The important thing is I'm going to try to hold the flashlight as steady as I can once we get to about 5 milliamps of current. Doesn't have to be exactly 5 milliamps, and 6 or 7 will work, but there we go, 5 milliamps. I can raise the voltage, so I don't want to get more light on there because that would overpower the resistor that we got to limit the maximum current. But there you can see I raised the voltage 4 times. I'm kind of moving the flashlight away, and the voltage, the current I mean, held steady right there. Change the voltage right there. Current's gonna hold steady as long as I keep the light in the same spot. So that's really about it. The photodiode passes a certain amount of current based on how much light is falling on it, regardless of the voltage. Of course, you need enough voltage to be able to pass the current, because ultimately the more current it lets pass, the more voltage is going to go across whatever is in series with it right there. So a lot of times you'll see a resistor in series with it. Then you can measure the voltage, and based on how much current is flowing, you can get a sense of how much light is falling on the photodiode. Main thing is though, as long as you got enough voltage, doesn't matter what the supply voltage is. The current will be limited by how much light is falling on the photodiode. Whereas if you used a light dependent resistor, its resistance changes based on light, so it will pass more current as the voltage goes up for a given amount of light. So that's the difference. Hopefully that makes sense. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.